Assalamualaikum warahmatullahi wabarakatuh, my dear students. Today we are doing the last lesson. I am so sad because we are going to be parted after this. Lesson 83, Introduction to Amino Acids. We are not going to learn how to produce amino acid in our daily life. We need to have 10 essential amino acids taken in our diet. So we need to learn what is the physical properties of it, what are Zetherion structure, and what is PI, Isoelectric Point. Then we go straight to the reactions of the amino part with HCl, nitrous acid, and acyl chloride, same as previous lesson. And then the reaction with carboxyl group by doing reduction with metal, alkali, and alcohol. So basically, we are doing all the reactions that we have done, but on the same compound which has two functional groups, which is amino and carboxyl. We are combining chapter 10 and 11 over here. In the Quran, in a few verses, Allah subhanahu wa ta'ala has mentioned that human beings, us, came from the soil of earth. Because it turns out that the elements that exist in the soil of earth is the same as the ones that is building us. The building block of us is amino acid, proteins, and all the elements are existing in the soil of earth. And then the verse are talking about how the first man, Prophet Adam alayhi salam, reproduce his offspring, Habil, Qabil, Iklima, and so on, all the twins, from human sperm, and then forming a clot, which is the embryo, the fetus, and then become the whole baby of human. Let's look at a surah, a chapter in the Quran that is very near to our heart. I believe a lot of you, most of you, memorized this surah. Surah As-Sajdah has how many ayah? Thalathun. Ahsan. Sentence number 7. The meaning or the translation is, who perfected everything which he created and began the creation of man from clay. Yes, the word is clay, not soil. Then he made his posterity out of the extract of a liquid disdained. That refers to the sperm. Then he proportioned him and breathed into him from his created soul, and made for you hearing and vision and hearts. Little are you grateful. So we have to be grateful for being able to live and breathe in today's world, the Mother Earth. This is a bit of information that I've Googled previously. It turns out that the elements of the periodic table that soil is composed of is listed on the left here. And I don't know whether it's coincident or not, but us human are composed of the same element, exact same element. So, who still does not believe that we are created by God? Allah subhanahu wa ta'ala. He is the greatest creator of all. There are so many papers and journals have been written by scholars regarding specific parts of the Quran, comprehensively stating the understanding of human body formation, starting from clay and then the liquid of sperm, and then a little blood clot, the embryo, and so on. So let's look at the illustration of it. Starting from number 1, Prophet Adam is created as an extract of clay from earth. And then number 2, we made him as a nutfah. Oh, this is not from Surah Sajadah, it's a different surah, because nutfah is mentioned in a different chapter. Number 3, the nutfah or the sperm turns into a clot. And then number 4, the clot turns into a little lump of flesh. Number 5, that little lump of flesh is then filled with or supplied with flesh and bones. And then number 6, Allah subhanahu wa ta'ala clothed the bones with flesh. And finally, we babies are brought it forth as another creation. So Allahu Akbar, the best creators of all. Every year, I tell my students, if we want to build a strong and big nation, we have to start by taking care of our family first. As mothers, yes, we would be thinking of what to feed our children every single meal. Make sure protein is in it, especially the 10 essential amino acid. Why? Because amino acid are the basic unit of proteins. When combined, it becomes long polypeptides. It has primary, secondary, tertiary, and quaternary structures. And the proteins are combined together to form hormones, enzymes, our skin, all the organs. So proteins are our building blocks. Everything is made out of protein. If we want to have a strong and healthy children, big ones, taller than us, their parents, we need to feed them a lot of proteins, good quality proteins, not processed meat. Okay? Proteins are natural polymer which is made up of polypeptides and amino acids. Alpha amino is when the amino group and the carboxyl group are attached to the same carbon. There are 20 amino acids exist that is found incorporated into proteins. Okay, this is the structure of a basic amino acid. For KSP, you've already learned this in biology. Organic chemistry is a pathway for you to do biochemistry, and biochemistry is a pathway for you to do biology. So you should be able to understand everything after this, inshallah. Here in the green box is an amino group, NH2. In the purple box is a carboxyl group. As you can see, it is attached to one carbon. This carbon is called an alpha carbon. This amino acid is called an alpha amino acid. The carbon in the middle here is a chiral carbon. Why? Because it has a different group attached to it. It has optical activity. The other two group is H and R. If the R is a H, as for glycine, it is not a chiral carbon. Therefore, glycine is the only amino acid that does not have a chiral carbon. Here is an example of an amino acid. Let's find the alpha carbon. Yes, here it is. How do you know this is the alpha carbon? Because a carboxyl group is attached to it, an amino group is attached to it, a hydrogen atom is attached to it, and the whole thing here is the R group. L-arginine is having Iupac name 2-amino-5-diaminomethyl-lidinamino pentanoic acid. It has healing powers where the role is very important in the production of human growth hormone. Human growth hormone is produced in the thyroid gland. There are 4 types of amino acid. The first one is neutral, when the side chain R is a hydrocarbon. For example, this is an alanine. It has methyl as the R group. The second category is an acidic amino acid, whereby it would have 2 or 3 carboxyl group. A basic amino would have extra amino group, and when we have hydroxy group, carbonyl group, and sulfide group, we are going to have a polar amino acid. Let's look at all 20 amino acids in brief. Firstly, glycine. Yes, the glycine I've told you before, the one that does not have optical activity. As you can see, the hydrogen here is the same as the hydrogen here. The side chain is a H. The second most simplest amino acid is alanine. We call it ALA. And it has methyl as the side chain. Valine has an isopropyl as a side chain. Leucine has an isobutyl. Isoleucine has a sec-butyl. As you can see, all the side chains here are hydrocarbons, so they are neutral amino acid. Phenylalanine has a benzyl group as its side chain. This is tryptophan. It's a basic amino acid. So as proline, also basic. Serine has a OH group, so it is a polar amino acid. So as threonine and cysteine. Methionine is important in cloning. It has an S, sulfur inside the side chain. And then tyrosine has a phenol part. Asparagine has also an amide part. The structure of glutamine is shown to you here. Having an amide group means it is also a basic amino acid. Aspartic acid and glutamic acid is an acidic amino acid. Why? Because it has two carboxyl group. I want to talk about glutamic acid for a while, because glutamic acid is a part of a kitchen salt that we use to add flavor in our cooking. Are you familiar with the word glutamate? Yes? Monosodium glutamate? MSG? Yes? I really want to take you out of the mythos. If you use MSG in your cooking, your hair is not going to fall out. Glutamic acid is an amino acid, so if it is in MSG, is it good or bad for us? Of course it's good. So instead of using NaCl, you might as well use MSG. NaCl has Cl, halogen. So we're not going to use halogen in our body. We're going to get rid of it. So might as well we use sodium glutamate, because sodium is used for our nervous system. But do not take it excessively because it will affect our blood vessels. Our elderlies got a lot of high blood pressure because of it. But we just use it a little bit in our cooking to make it more delicious. It gives us the flavor which is called by the name umami. Discovered by Japanese food scientists. So MSG is good, not bad. Here is lysine, arginine, and histidine. All three are basic amino acid. Now let's do the Iupac naming for amino acid. We are going to use carboxyl group as the parent name because it has the highest priority of group A. The amino, the side chain, and hydrogen would be the substituent. So we're going to have first example given, alanine. There are 3 carbons, so the name would be propanoic acid. And we have 1 substituent, which is the amino group. So amino group is attached to carbon number 2. We write it 2-amino propanoic acid. Serine. What is the name for serine? It has 1, 2, 3 carbon as well, so it's a propanoic acid. Yes, it's a 2-amino. Amino attached at carbon number 2. 3-hydroxy propanoic acid. Next, what is the name of aspartic acid? It has 2 carboxyl group, 1, 2, 3, 4. It's a butanoic acid. But since it is having 2 carboxyl, so we name it dioic acid. 2-amino butandioic acid. Lysine has 2 amino group. It has 1, 2, 3, 4, 5, 6. So it is a hexanoic acid where the amino group is at carbon number 2 and carbon number 6. So 2,6-diamino hexanoic acid. Let's look at the physical properties of amino acids now. Number 1, what are the physical states? It has to be in solids. Otherwise, what happened to the human body? It has high melting point generally over 200 degrees Celsius. It can form hydrogen bonding, so it is soluble in water and insoluble in nonpolar solvent. It is a bipolar molecule and it has the property of being an amphoteric, meaning that it would become a different compound based on the environment that it is in. In acidic, it would have a different charge. In basic solution, it would have a different charge. So depending on what is the pH the solution is given, the amino acid would behave differently. This is the one that I talked about earlier, optically active. The amino acids are all optically active except glycine because the side chain is the same as H. So this is alanine drawn to you where the chiral carbon is labeled by the asterisk. Okay, this is the Fischer projection of alanine. It has dextrorotary and also levorotary. The optically active carbon is also labeled as the asterisk. Amino acid can form Zetherion. What is Zetherion? Zetherion is a condition where in one same molecule, one atom can have positive charge and another atom can have a negative charge. So basically it's going to have an internal acid-base reaction. The amino acid is having a dipolar or bipolar ion reaction. This is making boiling point of amino acid high because of the strong ionic bonding exists between the amino group and the carboxyl group. This is the internal acid-base reaction where you see the lone pair of nitrogen is attacking the proton in carboxyl group where a H plus is going to be attached to nitrogen. So this lone pair is going to be used as the electron pair in the covalent dative bond, making this part of the amino acid having a positive charge, NH3+. And then the carboxyl group is going to lose its proton. So the bond here, as you can see, there is 2 electrons here at the covalent bond, will be taken by oxygen. So oxygen is going to have 1 electron more. So it's going to have a negative charge. This is an uncharged structure. And then when it is in a pH where we call isoelectric point, Zetherion is going to happen, whereby hydrogen here at the carboxyl group is going to be removed and transferred to amino group. This is the isoelectric point which I was talking about earlier, where it is a pH this particular molecule have an equal positive and negative charge. So in one molecule, when you have the same 1 positive charge, 1 negative charge, it would make no net charge, and the maximum concentration of the bipolar ion is called Zetherion. So for acid amino, every amino acid would have a specific pI. For example, alanine has the pI of 6.02. At this particular pH, alanine will exist as Zetherion, where it has one positive charge and one negative charge. So it is easy for us to understand that the pI for basic amino acid is higher than the pI for acidic amino acid. So alanine is considered as a little bit acidic because it's 6. Now, the pH for amino acid can be in the range of 5 to 7. 5 is acidic, 7 is basic. And here at pI, the proteins are usually insoluble, meaning that they are in solid form and form precipitation. Okay, let's consider when we want to put an amino acid in a solution that is acidic, for example, pH 1 or 2, and also in a different solution which is basic, for example, pH 12 or 13. So again, this is alanine. Alanine is going to behave like this, where it's going to be positively charged. Why? Because acidic solution has a lot of H+. H+ will be attached to N in amino group. And when it comes into basic solution, having a lot of OH- in the basic solution, the carboxyl group will detach its H+, where the H+ is going to be ionized to be freely attracted to OH- in the basic solution. So you should be able to draw the structures of amino acid when it is in acidic solution. It's going to have a positive charge. When it is in basic solution, it's going to have a negative charge. And also when it is in its pI environment, where it's going to behave as Zwitterion. In a molecule, it would have a positive charge and will have a negative charge. This is an example 11.13, where you have to draw lysine at pH 1, 9.5 and 12. So the question is giving you an information where the pI for lysine is 9.5. So at pH 1, you have to draw NH3 plus at both of the amino acid, because it's going to behave as a compound that has a positively charged group. Okay? In this case, it has 2 amino groups, so put 2 charges, 2 positive. And when it's in pI, just choose one group of the amino to become positive, and the carboxyl will become 1 negative. So it's become a neutral compound. And when it's in basic, remove the H from carboxyl and make it a negative charge. That would be the answer for this example. Okay, this is the example. We are making it using skeletal structure to make it faster for you to write down. As you can see, in acidic solution here, pH equals to 1, we have 2 positive charge. So lysine behaves as amphoteric molecule, whereby in an acidic solution it has a positive charge. At pH 9.5, Zetherion will be formed, whereby in one molecule there would be 1 positive charge and 1 negative charge. You can draw it like this. Or you can draw it like this. Just choose one of the amino group to become the positively charged part. And this is when lysine is at pH 12, basic. You're going to have a negative charge at the carboxyl group. Okay, now we come to the chemical reaction of amino acid. As we have known, the most important group in amino acid would be the amino group NH2 and carboxyl group COOH. So the reaction would be divided into two as well. So all of the reactions that we're going to do here is a quick revision for you where we have learned this before. The first one is the reaction of the amino group of amino acid with HCl. So we're going to form an ammonium salt here. Next, the second one is the reaction of the primary aliphatic amine part of the amino acid, where when it comes to reaction with nitrous acid, the diazonium salt is going to be decomposed and formed. The observation is bubble gas form, having the carboxyl ion producing alkene, alcohol, and haloalkane. And then the last one would be the reaction of the amino part of the amino acid group with acyl chloride. So it's going to form an carboxylic acid derivative where an amide compound will be formed. The second part of the chemical reaction would be the reaction of carboxyl group, where it's going to be reduced to become primary alcohol. It reacts with reactive metal to become sodium alkanoate. Reaction with alkali also will produce sodium alkanoate, and the reaction with alcohol is called esterification. Okay. Now let's do example 11.14. This is in your course book. When we react this amino acid with HCl, okay, we are going to add in the hydrochloric acid molecule inside the amino part, whereby N would have 4 bonds. Okay, this one bond is using the lone pairs, and HCl will be attached to it. Example 11.15 is the reaction of nitrous acid with the amino part of the amino acid. So what we're going to have is the alkene, alcohol, and haloalkane together with the observation where the nitrogen gas will be released. Okay, take some time to copy this down in your book. Example 11.16 is the reaction of amino acid amino part with acyl chloride, where HCl produced is going to give observation acidic white fumes formed. We are going to produce an amide. This is the product where one free hydrogen is going to give way for the attachment between N of the amino acid and the carbonyl carbon of the acyl chloride. Example 11.17 now is the reaction on carboxyl group of the amino acid, where we're going to reduce it to become a primary alcohol. Now, alcohol is the parent, because alcohol is having a higher priority than amino in group A, remember? Example 11.18 is the reaction of the carboxyl part of amino acid with sodium metal. It will remove H plus, and Na plus is going to attach to it, since the reduction potential of sodium metal is higher than hydrogen. Example 11.19 is the reaction of the carboxyl part of amino group with sodium hydroxide, where again the H from the carboxyl group will give way to sodium to be attached to it, forming sodium alkanoate. Example 11.20 is the reaction of carboxyl part of amino acid with alcohol. This is an esterification. We have a reversible reaction over here. So what will be produced is an ester. You need to be able to name this ester, but this is quite a big compound for you to name. I hope the question would be take an easy grab on you. The last part of amino acid reaction is peptide bond formation. This is a very important part as chemists going to be biochemists. A peptide bond is a chemical bond that is formed between two molecules of amino acid. So the part is one carboxyl group in one compound and one amino group in another compound. So we are actually attaching two amino acids together. This is a dehydration synthesis reaction, and we also called it condensation reaction. And if we want to categorize it as polymerization, it is considered as condensation polymerization. I apologize to you since this part is not in your course book. You can write this example at the back of the practice, the last practice in chapter 11. So how are we going to make peptide bond? Okay, as we say just now, peptide bond will happen between carboxyl group of one amino acid and amino group of a different amino acid. So this is a general formula or general reaction of how we are going to form peptide bond. So the OH part of carboxyl will join hydrogen atom of amino to eliminate this small molecule water, H2O. What is going to happen is an amide bond formed between the carbonyl carbon and the nitrogen of amino group. The hydrogen, the free hydrogen, is giving way for attachment between nitrogen and carbon. So this is an amide bond or amide linkage, which we called peptide bond. Drawing a specific example, 11.21, this is an alanine where the side chain is a methyl group and another molecule of alanine. So what will happen here is H2O will be eliminated and the peptide bond is going to be formed between nitrogen and the carbonyl carbon. Another example is in between glycine and glycine. Remember, glycine is the smallest homologue of amino acid where the side chain is H. It's the only amino acid that doesn't have a chiral carbon. So again, H2O is going to come out and peptide bond is going to be formed between nitrogen and carbonyl carbon. This is gly-gly, peptide bond formation. You can also draw a peptide bond formation between alanine and glycine. So as you can see here, on the left is the alanine part where the R is methyl. On the right is the glycine part where the side chain is a H. Oh, why there is too much, madam? This is the last one. Okay, now we put glycine on the left, just to show you that we can do peptide bond for everybody. I mean everybody in the 20 amino acid. So glycine is on the left now. As you can see, this is the side chain and it's going to form peptide bond here. And then alanine will be on the right. This is the side chain. This would be your homework doing the tutorial question of number 13, 14 and 15. Allahu Akbar, we have finished. Yes, seriously, we have finished. So I thank you very much. KSP, KSF, you have been listening to me throughout the whole year of session 2020 and 2021. I apologize for every mistakes and bad things that is coming from us. All that we have teach you, the good things are coming from Allah, our Creator, Subhanahu wa Ta'ala. And also, we pray for your success. You have a bright future ahead of you. You are the future leaders of the world. Please do a lot of things. Take care of yourself and make your parents happy. You are the apple of your parents' eye. Okay, thank you, everybody. There's nothing much I can say. It has been a great year with you, doing classes online, and you have been very helpful and cooperative. That's all. There's nothing much I can say. Assalamualaikum warahmatullahi wabarakatuh wa maghfiratuh wa ridwanuh ila yaumil akhir. Bye.